So on the blank back page, you wrote verify the lengths of 14, 15, and 11 form a triangle. Is the triangle acute, right, or obtuse? So the first thing we talked about on Friday, is the only thing we talked about actually, was deciding what kind of triangle you have, acute, right, or obtuse. But before we decide what kind of triangle, we have to know that it is a triangle. So the first thing you want to do is verify that you have lengths that can form a triangle. So think about if you had a 5-inch line and 2 inches and 2 inches. I know I just have a rough sketch, but do you think the 2 inches and the 2 inches are long enough to connect if the bottom side is 5 inches? Just think about it. What's 2 plus 2? 4. Okay, so even if they were laying flat, it wouldn't be long enough. So here's the general rule. You take the 2 smaller sides, you add the 2 smaller sides, and they need to be bigger than the largest side. This is how you decide if you have a triangle in general. So in our problem, what are the 2 smaller sides? 14 and 11. Is 14 plus 11 bigger than the biggest side, which is 15? Yes, because 14 plus 11 is 25. So this does form a triangle. Okay, now that we know it is a triangle, you will need to show me how to verify, because sometimes it might give you one that's not a triangle. You would just say, not a triangle, and you move on with your life. But if it is a triangle, you are going to use the Pythagorean theorem to decide what kind of triangle that you have. So what does the Pythagorean theorem say? A squared plus b squared equals c squared. So we're going to use the theorem to decide what kind of triangle we have. You may or may not, this equal sign may or may not be correct. If a squared plus b squared equals c squared, what kind of triangle do we have? A right triangle. If the hypotenuse squared is larger, like it says at the bottom, if the hypotenuse squared is larger than the leg squared plus the leg squared, you have an obtuse triangle. If the hypotenuse squared is smaller than the leg squared plus the leg squared, you have an acute triangle. And we'll talk about it. We're just going to plug in. So which of the side lengths that we have, which of them are going to be C? 15. It is the longest side. So 15. Which means the other two, 14 squared and 11 squared, are the legs. You will want a calculator out. 14 squared is?
196.
11 squared is? 121. 15 squared is? I got you. 225. Alright, so 225, I just dropped that down. 196 plus 121 is? 317. They obviously do not equal, so we do not have a right triangle. We need to decide what kind of triangle we do have. So, maybe. Which of these, we want to decide about the hypotenuse squared. If the hypotenuse squared is larger, it is obtuse. If the hypotenuse squared is smaller, then it is acute. Which of these numbers represents the hypotenuse squared? 225. So is 225 larger or smaller than the leg squared plus the leg squared? It is smaller. So this is acute triangle. You do not need to flip to the front page because I'm going to talk to you about today's lesson. It came to my attention that you guys did not learn. This lesson is called SOH CAH TOA. And you were supposed to have already learned what this phrase means, but you have not, which is fine. So I'm going to tell you along the way why we're doing what we're doing, but it's really not going to connect the dots until tomorrow when we actually start solving for things. But today's main purpose is to memorize what SOH CAH TOA stands for. All right? And then tomorrow we'll start applying it to things. So, you're still on the blank back page. In right triangles, well, let's back up for a second. Chapter 9 is about trigonometry. What is trigonometry? The study of triangles. And in your case, right triangles. Right triangles are so important if you decide any math field, science field, or even business. you're going to have to take trigonometry or calculus, which deals with trigonometry. Okay, so right triangles are so important in life. Look at this right triangle. What is the difference between the lowercase letters and the uppercase? What do the lowercase letters stand for? The sides, and the uppercase letters stand for the angles. So keep that in mind when we go through today. The goal of this chapter is to find missing sides and angles. Okay? These sides will actually represent like lengths and heights and like things that matter in real life. We're going to talk about a lot of like word problems and things. But you've already learned part of it. If you are given two sides and you need to find a third side, what do we use to find that third side? The Pythagorean theorem. So here's what you're going to write. There are going to be three situations that you'll be put in this chapter. The first one is, and you're going to write this down, the first scenario where you're given two sides and you need to find a third. And you will use the Pythagorean theorem. So go ahead and write that in. Scenario 1, I'd put a number 1. When you're given two sides and you need to find a third side, you're going to use the Pythagorean theorem. So are you given two sides? Do you need to find the third side? You're going to use the Pythagorean theorem. Or you can write a squared plus b squared equals c squared. Notice that all of the letters are lowercase. What do lowercase letters mean to me? They're sides. So can I plug an angle into the Pythagorean theorem? No. It only deals with the side lengths. Okay, so no angles. Not ever. You can't plug an angle into the Pythagorean theorem. You can't find an angle using the Pythagorean theorem. You will only ever use it for sides. Okay, and in this specific case, you're given two sides, you need to find the third. You're going to use the Pythagorean theorem. All right, there are two other scenarios. One of them is if you are given a side and an angle. This is scenario 2. If you are given a side and an angle, so go ahead and write in scenario 2. You could be given a side and an angle. And you can't plug an angle into the Pythagorean theorem. So that is why we learn about trig ratios, which are SOH CAH TOA. And we will talk about what that stands for and why it's a crazy word in a minute. But if you are given a side and an angle, you will use trig ratios. Okay, what do you think trig is short for? Trigonometric, to be specific. Okay, so if you're given a side and an angle, use trig ratios. If you're given two sides and you're finding an angle, this is scenario 3, it is the last one, you will still use trig ratios. Because again, you cannot plug an angle into the Pythagorean theorem. You can only plug sides into a Pythagorean theorem. Okay, so all today is learning what SOH CAH TOA stands for so that you can learn the very foundation to the rest of the chapter. So I'm going to try to teach you why we're doing what we're doing, but it might not click for you until we start like solving for things tomorrow. Capiche? I've already lost you, I could tell. What did I just say? Okay, so we're learning SOH CAH TOA. At this point, you can flip to the front. You need to memorize SOH CAH TOA and what it stands for. It is an acronym. What is an acronym in real life that you can say out loud here?
GOAT.
Yeah, what does GOAT mean? Greatest of all time. You all know what it means. SOH CAH TOA, each letter stands for something. Okay, so the first letter, SO, S stands for sine. Go ahead and write that in. We are on the front page now. S stands for sine. C stands for cosine, and T stands for tangent. S stands for sine, C stands for cosine, and T stands for tangent. These are called trig ratios. Okay, what does a ratio look like? It can look like many things. What do they look like? A what? Thank you. That's the number 1. That's what we're going to be saying. Fractions. Fractions are ratios. So here's what happens. Sine is equal to a fraction. And these letters, and now I'll show you what they mean. This is what we're going to be having. Sine of something equals the, and we'll talk about the letters. Okay? So these are all fractions. What I want you to do is write in each letter that OH, AH, and OA stand for. We're going to start with sine. Sine is the opposite, so you're going to write in opposite So sine is the opposite over, what is h? Think of right triangles. What's an important h word in a right triangle? Hypotenuse. Good. Sure. Opposite and hypotenuse. So, SOH. This next one, people spell wrong. If you call your friends "ka," Fran, I'm talking to you. If you call your friends "ka," a lot of times students spell this one wrong because it is CAH. I don't know how you spell it if you call your friend "ka," but it is CAH. So get it in your mind. CAH. A stands for adjacent, and H still stands for hypotenuse. So, ka. Yeah, if that's how you want to remember it. I don't care. And then toa. Think of toa like boa. What is a boa?
Brother.
You got a boa?
Yeah.
A snake.
Is a snake.
My boy.
You call your friends boa?
Yeah.
Okay, that's fine. Boa. These letters you already know. What does O stand for? Opposite, and A stands for adjacent. So, ka, toa. You will use this in Algebra 2, and it gets way harder in Algebra 2. Okay, so here's what's going to happen. These are called trig ratios. These are fractions. So sine is equal to the opposite over the hypotenuse. Cosine, this is just a different way to look at it. Some people like it the way I wrote it in white, and some people like it the way I wrote it in yellow. It doesn't matter to me, but you need to remember what SOH CAH TOA stands for. Sine is equal to the opposite over the hypotenuse. Cosine is equal to the adjacent over the hypotenuse. And tangent is equal to the opposite over the adjacent. Okay, so I want you to look at each of these fractions. Do any of them look identical? No. They're all different in their own way. They're all rotating the letters O, A, and H, right? So you need to remember SOH CAH TOA. Okay? This is called sine and cosine. They both have the hypotenuse on the bottom. Sine is so O, and then ka, and then toa. Okay, so why in the world are we talking about this? I will show you what it looks like. This is what a question on your quiz will look like, and I will show you how to apply what we're talking about. Okay, so find the trig ratios from the smallest acute angle. So first, we need to figure out what is the smallest acute angle. The smallest acute angle will be across from the shortest side. So what is the shortest side here? What number is the shortest side? 6. So what angle is across from 6? C. So I want you to put a little arc here. Because this is your perspective. You are looking into the triangle from this angle. And here's why it matters. We're talking about SOH CAH TOA. Where's your hypotenuse in all of this? Which one is it? The hypotenuse?
10.
Why is it 10? Because it's across from the right angle, because it's the biggest number. Go ahead and label it. This is the hypotenuse. The other words are opposite and adjacent. So, Caleb, the way that you sit right now, who is opposite of you? Don't overthink it. Look straight. Who's opposite of you? Noah. Who's across from you? Opposite across. Who is across from you? Noah. If you turn 90 degrees that way, who's across from you? Opposite of you. It would be Michael. So here's what matters. Your opposite will change based on what angle you are looking from. So when I'm looking from angle C, what is opposite of angle C? 6. So go ahead and label it as the opposite. It is opposite of my angle. So we've got hypotenuse, we've got the opposite. My remaining side will be the adjacent. Adjacent means like they share a wall, they're next to each other, that kind of thing. Okay, so we've labeled our sides. Now we are going to find sine, which we shorten, S-I-N, But you do not call it SIN. You call it sine. If you walk in, if you walk into either Algebra 2 classes saying sin, you will, like this sin, you will probably get smacked with a book. Okay? This is sine. Okay? Sine, and what angle are we using to look into the triangle? From what angle are we labeling these? C. So you're going to put sine of C. You have to put a letter here, or you're not correct. Not even close to correct. Okay, so sine from angle C equals the opposite over the hypotenuse. Now, I'm not going to keep this here, this O over H. I'm just reminding you, opposite over hypotenuse. What is the opposite length? 6. So opposite of C is 6. And then what is the hypotenuse's length? 10. Do we reduce in math? We do. What is 6 over 10 reduced to? 3 over 5. 3/5. That's it. That's all for sine. So when it says find the trig ratios, how many trig ratios were there? 3 of them. So we got to move on to cosine. So cosine, again, from what angle? Same angle, so it's going to be C. Okay, remember, you can't leave it blank. Cosine from angle C. How do you spell ca? C-A-H. So the adjacent goes first. What is the adjacent? 8, and then the hypotenuse? 10. This reduces to? 4/5. Last is tangent, again, from angle C. How do you spell TOA? How do you spell BOA? It's the same way. O over A. TOA. So, opposite, which would be? Over the adjacent, which is 8. This reduces to? 3/4. This is literally the answer. So I'm going to try to explain why we're doing this, and then we're going to move on. This is literally just the foundation of everything. Here is what's happening. We said that sine from C equals 3/5. This is an equation. How do I know it's an equation? The equal sign. What is missing in this equation? Sure, yes, but what variable is it? What do I not know the value of in this equation? I know there's a lot of letters. C. What does this capital C represent? The angle. Do we know the value of this angle? Do we know the measure of this angle? No. We don't have enough information inside to know it. But here's what we do know. What you're going to learn is that with 2 buttons, you're going to be able to find the measure of angle C using this equation. So you're learning to set up this equation so that you can find things later on. And that's all. So we're learning to memorize SOH CAH TOA so that we can apply it later. I'm going to go to the next question, seeing as you guys are all riveted. Write the sine, cosine, and the tangents from angle C. When we look at this triangle, does it look complete?
Yes.
It does not look complete.
No.
It's missing the G.
It's missing a side, right? It's missing AB, right? So how do I find that missing side? The what? The Pythagorean theorem. That is it. A squared plus B squared equals C squared. Let's go ahead and write it in. We got to find that third side before we find sine, cosine, and tangent. Missed. All right, so which of these is C? Which of these is the hypotenuse?
50.
50. It is 50.
Thank you.
All right, A and B, I don't know this side, so I'm just going to call it X, because why not? And then we'll say 48 is B. What is 48 squared? 2,304. And 50 squared is 2,500. That one's easy as 5 squared, ding dong. We'll subtract. 2,500 minus 2,304.
196.
196. This is a perfect square. The square root of 196 is?
Wait, don't tell me. We just did it. 14.
It's 14. We did not just do it. So what did we just find?
On the back.
Oh, you're right.
We found AB.
We found AB? So all we did was find the length of AB. Okay? We need to find sine, cosine, and tangent. So before we do that, we need to label them. We already labeled the hypotenuse. Is the hypotenuse ever going to change? No. It's always the longest side. It's always across from the right angle. But our opposite and our adjacent, they matter. We're coming from angle C, like they said in the directions. So from angle C, what is my opposite going to be? 14. If you struggle with it, you can always turn your paper towards you, like the angle towards you, and see what's across from you. Okay, so 14, and then that means 48 is? 48 is adjacent. Because we already have a hypotenuse, and it's 50. Remember, hypotenuse is always the longest side. And then our opposite is across from us, and then the adjacent is what's left. All right, so let's talk about sine, cosine, and tangent. Sorry, I didn't mention this is how you shorten them. Again, you still call them sine, cosine, and tangent. Do not call them cos or tan. You will get corrected, and it's just not, it's not good. All right, what sine from, we said angle C. Okay, and it will be the opposite over the adjacent. So, opposite over, no, I lied. Opposite over hypotenuse. Sorry, I said the wrong thing. Sine is opposite over the hypotenuse. So, what is opposite?
14.
14. And then my hypotenuse is 50. All right, and this reduces to? 7 over 25. They're both divisible by 2. Go to war. Cosine from C. Cosine, how do you spell cosine?
COSINE.
Yes, in SOH CAH TOA, how do you spell
Oh.
Sorry. CAH. Okay, so A is adjacent. What is the adjacent length?
40.
And the hypotenuse?
50.
50. Reduce it and you get?
24 over 25.
You're correct. 24 over 25. Tangent from C. How do you spell the SOH CAH TOA? The TOA? TOA. So opposite goes on top, which is?
14.
Is it? Yep, 14. And then the adjacent?
48.
This reduces to?
7 over 24.
7 over 24. So keep in mind, you might be asked, I know for sure on your homework you are, once on the back. So on the back it says find the value of each trig ratio rounded to the nearest. Your homework says 10,000th. Can you listen? Your homework says 10,000th. We're going to round to the 1,000th just to show how to do that. So like if it says round to the 1,000th, how many zeros are in the number 1,000?
3.
There's 3, so you're going to go 3 decimal places. So here's what you would do. You would take either of these fractions, because these are equivalent. Take either of these fractions and go ahead and divide them in your calculator. What is 14 divided by 50? Or 7 divided by 25? Same thing. Type it in. 0.28. So all you would do, if it said round to the nearest 10,000th or 1,000th, you would put 0.28 and then it's a 0 because there's 3 decimal places, but that's it. So on your homework, it's going to ask to make it a decimal. You just type this number in. 24 divided by 25, this next one. Do you want to try it? 24 divided by 25. 0.96. I'm only adding a 0 at the end because I said the 1,000th, which is 3 decimal places. And then the last one, 7 divided by 24.
0.292.
So 0.2916, that's 6. Is it going to make the 1 round up or stay? It's going to make it round up to a 2. Okay, so keep in mind, it may ask you to make it a decimal. All you do is you find the same fraction and you make it a decimal. We know fractions and decimals are the same thing, right?
Yes.
Okay. When you're ready, go ahead and turn to the next page. We practice like this one more time. If it, what do you mean?
Like, say it does do decimal.
Round up if it's applied. So like that one said 0.2916. What was the number after it? Do we know?
6.
Oh, it was a lot of sixes. Okay. So it depends on how much it said. If it said the tenths place, how many zeros are in the 10? 1. So it would say 1 decimal place. You would need to decide if this needs to stay or go up. So would this stay or go up? It'd go up because there's 9. If it said the hundredths place, which is 2 zeros, would this 1 make this 9 go up or stay? Stay. And then, like we said, this is the thousandths place. Would this 6 make it stay or go up? Go up. And then, keep on going. 10,000ths place. Would this 6 make it stay or go up? Go up. So you look at the number right behind. Okay. All right. We do one more like this, and then I'll show you what your homework looks like. Write the sine, cosine, and tangent ratios from angle A. So what do we notice about this triangle?
It's a right triangle.
It is a right triangle. What else do we notice? It's missing a B. It's missing a side. So how do we find the missing side in a right triangle?
Pythagorean theorem.
Pythagorean. Yeah. A squared plus B squared equals C squared. We're given 2 sides. We can find the third side using the Pythagorean theorem. So A squared plus B squared equals C squared. Which of these is going to be C? 34. Correct. Is the hypotenuse. So that means x squared plus 30 squared. So x squared plus 900. What is 34 squared? 1,156. He beat you to that one. Subtract 900. Mackay's in your head?
Yes.
Why? 1156 minus 900 is 256. You're weird. What? Treyon, how do we finish this problem? How do I get x by itself?
Oh, use square root.
Take the square root. What is the square root of 265 or 256? It's 16. So that means my missing side is 16. This side. So we are going to solve for a lot. We're going to solve for sine, cosine, and tangent. We're going to write them at least. So sine, from what angle are we doing this one?
Z. Don't A. I'm tripping.
How do I know it's angle A?
Because it says so on
It says it in the direction. Sine from A, cosine from A, and what is it? Tangent from A.
Get it? Cosine? Like cosine?
Yes. Do you know Mr. Cosin?
Mr. Who?
Mr. Cosin?
Who's that?
He used to, well, he does a lot of the t-shirts. That's why he's called Cosine Designs. He used to teach math. He also used to coach basketball. It's fine. And he taught Algebra 1 this year.
You did?
Well, while Miss Johnson was gone. Yeah. Anyways, okay. So from angle A, we need to label all of the sides. Okay? So, from angle A, my hypotenuse, I already labeled it because we plugged it into the Pythagorean theorem. Okay? So, which of these is my opposite?
16.
No.
30.
From angle
30.
A
Oh, from angle.
is 30. So, your opposite, this is angle A, right? I just outlined the measure of angle A, that whole thing. It's not going to be either of the sides it's connected to. It's going to be directly across from it. So 30 is the opposite, which means 16 is the adjacent. All right, so we're doing it again. So what is my fraction going to look like? 30 over 34. Does this reduce?
Yes.
It does. What does it reduce to?
15 over 17.
15 over 17. They're both divisible by 2. Cosine. What are the 2 letters there? Cosine is
That's
ca.
16 over.
Well, adjacent over hypotenuse is what I'm looking for. The adjacent is 16. You're correct. Over 34. They're both even, so they're both at least divisible by 2. 16 over 34 reduces to?
8 over 17.
8 over 17 is correct. All right, and then tangent. Tangent is TOA, right? So tangent is opposite. What is the opposite? 30 over the adjacent, which is 16. Does this reduce?
15 over 8.
Yeah. Leave it like this. Improper fractions are perfectly fine. You are officially at a higher level of math. Leave it alone. No mixed number, no decimal. Leave it like this. It's beautiful. All right, so that is what your quiz will look like on Thursday. You're going to be given triangles, and you'll have to tell me sine, cosine, and tangent. Okay? We're going to do these. We're going to do 2 of these. This is what your homework looks like. We're going to do 1 and 3. So starting with 1, I'm going to tell you one trig ratio to find, and you're going to tell me what it is. So what angle am I looking into this triangle from? Yeah, I'm looking in from A. So I'm looking in from here. Sine, so is opposite over hypotenuse. So I really only need to label the opposite and the hypotenuse. You can label all the sides if you want to, but I really just need opposite and hypotenuse. Which of these is the hypotenuse for sure?
30.
30 is the hypotenuse. It's the biggest side. It's across in the right angle. Which of these is my opposite?
24.
24. Which does mean this is adjacent, but I don't need the adjacent. I just need the opposite and the hypotenuse. So my fraction is going to look like 24 over 30. You're not correct.
Whoa, 12, 15.
Okay, still not correct.
Uh-huh.
They're both divisible by 3. Keep going.
Uh-huh. Oh, 3 over 4. 4 over 3.
12.
Okay,
3 over 5.
guys, you're too
4 over
much.
5.
Okay. Okay, first off, you can try on divided by 2 and then divided by 3, which means in general you could have just divided by 6. Okay, what's 24 divided by 6? 4. 30 divided by 6 is 5. You can divide by 2 and then reduce it again, but you got to make sure it's in its most reduced form, which is 4/5.
Told you.
Yeah. Number 3. Okay, we want to find cosine from C. So again, from angle C, because it told me. Which of these is my hypotenuse?
25.
25. Which of these is my opposite?
15.
15. And then the last one is 20 is
The
adjacent. Cosine is what side over what side? Adjacent over hypotenuse. So what is my fraction going to look like?
20 over
20 over
25.
25. They're both divisible by
5.
5.
4 over 5.
Correct.
No.